Welcome to today's Explainer. I was digging through some expert facilitator guides on value engineering recently, and it hit me. We might need a total reset on how we think about project optimization. Today, we're going to completely flip the script on that old, tired habit of thinking cheaper is always better. We're elevating our mindset to a true life cycle perspective of value. So, whether you're in engineering, procurement, construction, or honestly just fascinated by how massive decisions get made on complex projects, you are absolutely in the right place. Let's get right into it.
Okay, let's dive into this because it's a fundamental question that trips up even the most seasoned project teams. Is cheaper always better? We've all been conditioned to think that finding value just means, well, getting a discount, right? We look at two bids, maybe two design options or materials, and our gut instinct just naturally gravitates toward the lowest price tag. We think, hey, we're saving money, we're doing the company a solid. But today, we are going to completely shatter that universally accepted myth. Finding true value is absolutely not just a matter of snagging a discount.
In fact, our source material draws a really hard line in the sand here. It states, and I quote, "Value engineering is not cost-cutting wearing a badge." I absolutely love this line. Cost-cutting and value engineering get mixed up all the time in the field. Sometimes it's even intentional. Folks trying to pass off cheap work as strategic optimization. But they are totally different beasts with completely different outcomes. Today, we're putting an end to that confusion once and for all.
Here is our roadmap for today. First, we'll establish why value is not a discount. Second, we'll break down the core value equation. Third, we're looking at the 3 legitimate paths to raising value. Fourth, it's VE versus cost cutting. And finally, number 5, the life cycle reframing.
All right, Section 1, value is not a discount.
We've really got to start unlearning this bad habit of traditional cost cutting. Simply put, if function goes down just to save money, that is cost cutting. It's really that simple. It's kind of like switching the office to have ply toilet paper to save a few pennies, right? If the quality, the performance, the safety margins, or the reliability of a project silently erode just so a team can hit some arbitrary budget number, you're not doing value engineering. You're literally just cutting corners. A cheaper part that fails sooner, that hasn't created value. It's just hidden a cost and pushed it downstream for someone else to deal with later. With true value engineering, quality, performance, and reliability absolutely must be held constant or improved, period.
Moving on to Section 2, the core value equation. Now, what's really interesting here is this introduces a completely new mental model. This is the single mathematical sentence that the entire discipline of value engineering is built on. Value equals function divided by cost. Value is fundamentally a ratio. It's the function a design delivers divided by what it actually costs to deliver it. It is not just a single price tag on a purchase order. Function is what an item actually does in the real world. Think, transfer heat or contain fluid. Cost is simply what it takes to achieve that function. Because of this, two designs can have equal value at very different costs, or they can cost the exact same amount but deliver wildly different value. Cost alone, it never tells you which is the better decision, only this ratio does.
Okay, Section 3, the 3 legitimate paths. So if value is a ratio, how do we actually manipulate it? Well, there are exactly 3 real mathematically valid ways to raise value. 1, you can increase function while holding the cost steady. Basically, you get more performance for the exact same money. 2, you can hold the function constant while reducing the cost. You get the exact same performance, it's just cheaper. Or 3, you can improve both simultaneously. Function goes up, cost goes down. Now, in all 3 of these valid paths, notice what happens to the top half of our fraction. You must always protect the function side of the scale. But here is the dramatic contrast. The one forbidden move. Cutting function to cut cost. This is the one move that only looks like value engineering to an untrained eye. If you reduce the function just to reduce the cost, you are lowering the numerator and the denominator at the exact same time. So the mathematical ratio of value might not even improve at all. The team hasn't actually optimized anything. They've simply reduced the scope of the project. This is the ultimate test every single idea in a workshop has to pass. Let's move to Section 4 and see how this builds VE versus cost cutting. Let's set up the ultimate showdown between the right way and the wrong way to save money. This definitively untangles value engineering from that dirty word cost cutting. Just look at the starting question. VE asks, what function must this deliver? Cost cutting just asks, how do we make this cheaper? Next, look at the effect on function. In VE, it's held constant or even improved. In cost-cutting, it's silently reduced. What about the method? VE relies on a structured, cross-functional team study, carefully weighing alternatives. Cost cutting? That just relies on unilateral trimming and value shopping without any real functional review. And the typical result? VE yields a lower lifecycle cost with equal or better performance. Cost cutting might give you a lower first cost, but it almost always leads to risk, rework, and downstream failure. Honestly, once you see them side by side like this, there is no way you can ever confuse the two again.
Finally, Section 5, the life cycle reframing. So the crucial point is this. To truly master the value equation, we have to widen our perspective of time. We need to redefine what the word cost actually means at the bottom of our fraction. First cost is literally just the capital price to procure and install an asset on day one. But life cycle cost, that's the true total cost of ownership. It is the capital cost plus operating, maintenance, downtime, and eventual disposal costs over the full working life of the asset. A team that only compares first cost is going to regularly recommend the wrong option. A cheaper first cost can easily become the absolute most expensive choice once all those operating and maintenance costs get added to the ledger over the years.
To put that into perspective, just walk through this 10-year horizon. At year 0, you have your capital cost. And hey, the cheapest bid looks great here. But then comes year 1 with operating costs. By year 5, you're hitting maintenance and rework because, well, that cheap part just couldn't withstand the daily pressure. And by year 10, you are facing eventual replacement way sooner than you ever should have. True value engineering considers this entire timeline. It protects the project across its whole service life, making sure that the cost in our value equals function divided by cost equation is the honest lifecycle cost, not just some deceivingly low day one price tag.
So as we wrap up today's explainer, I want to leave you with this final provocative thought to take back to your own teams and your own projects. When you review your next budget or when you sit down to evaluate your next design alternative, ask yourself, are you truly engineering value, protecting function, and lowering lifecycle cost, or are you just silently cutting corners? The difference is literally everything. Keep that value ratio in mind, and I'll catch